Good morning, class. Okay, this is Mr. Mtene William. Today we are going to concentrate or focus on light. Yeah, as you can see, this is our diagram. The diagram that we have this line. This line is called the normal, and we have the surface here, the demarcation between the two mediums. We have the air medium there and water medium there. Okay, so before we answer these questions, we need to look at some properties, light properties. Yes, according to the property of light, the incidence ray and the normal ray makes up the angle of incidence. The incidence ray and the normal ray makes up the angle of incidence. So now, if we look at this one, we can see that this is 90 degrees. This is also 90 degrees. So now, the incident ray, if the light is bouncing back, the refracted ray and the normal also make up the angle of refraction. The angle of refraction and the angle of incidence are always equal. The angle of incidence and the angle of refraction are always equal. Wonderful. So now, the other thing that we are going to look at is when the light is moving from one medium to the other, we can see that these are two different mediums. We have water, we have air there, and water here. Okay, so this side is air, this side is water. If we look at the two mediums, when the light is moving from a lesser medium to a less dense medium to a more dense medium, the light will bend towards the normal. So we can see that the air is less dense than water. Water is more dense. So the light will bend towards the normal since it is moving from a less dense to more dense. If the light is moving from a more dense to less dense, the light will bend away from the normal. Away from the normal. Away from the normal. That is the property that we need to understand. Okay, so let's answer the following questions. They are saying determine the angle of incidence. On number 2, they are saying determine the angle of refraction. Determine the angle of, or determine the refractive index. Then this one, determine the critical angle. We need to calculate all these today. My name is Mtene William. You can join my tuition center. I do physical and online tuitions. Yes. So for us to find the angle of incidence, we need to know that this angle is 90 degrees. Equally, this angle is also 90 degrees. And remember, the incidence ray and the normal make up the angle of incidence. So if we have a 90 degrees here and we have a 20 degree here, we know that what we have here is 70 degrees. We can even prove it. So the angle of incidence will be equal to 90 degrees minus 20 degrees. If we subtract the two, we are getting 70 degrees. So this is done about the angle of incidence. Number 2, we are going to find the angle of refraction. As we know, refraction is the bending of light as it moves from one medium to the other. Okay, so now, as light moves from air to water, it is moving from a different medium to another medium. Always light bends as it moves from one medium to the other. So, once the light enters a different medium, this ray is now called the refractive ray, and the angle it makes, the incidence ray, the refractive ray, and the normal makes up what we call angle of refraction. So this is the angle of refraction. How are we going to determine the angle of refraction? We know the angle here has been given from here to there. It is 131 degrees, and if we know this is 90 degrees, then it is very easy to determine this. So we are just going to say angle of refraction is equal to 131 degrees minus 90. We will just subtract 90, then we'll remain with this one, which is going to give us 41 degrees. Number 3, they are saying the refractive index. For us to know the refractive index, we need to consult the Snell's law. According to Snell's law, it says angle of the refractive index is equal to sine incidence over sine refractive. So, what is our sine index? We need to use the angle of incidence. This I is standing for the angle of incidence. This R is standing for the angle of refraction. How are we going to do it? We'll simply substitute. We are going to say sine incidence, which is 70 degrees, over sine angle of refraction, which is 41 degrees. Okay. So if we work out using a calculator, we are going to get 1.43. Remember, refractive index has got no units. This is a constant. Let's do it with number 4, the last one, the critical angle. How do we find the critical angle? It is very simple to find the critical angle. We simply say critical angle is equal to sine inverse over 1 over refractive index. Critical angle is equal to sine inverse over or multiplied by 1 over refractive index. Critical angle is equal to sine inverse of 1 over refractive index. So now we are going to substitute here. We are going to say sine inverse 1 over, what is our refractive index? Our refractive index is 1.43. Okay, just like that. So now, on your calculator, can you punch this? On your calculator, can you punch this? I didn't come with my calculator, but you can punch this. That is how we work out this. Thank you very much for watching, and please, you can join us. You can join us our physical tuition center and our online. Thank you very much.